Good afternoon today. To our next webinar. We want to talk today about virtualization and how DSS will fit into the virtual environment. We want to show Iskazhi Failover running in a virtual, totally in a virtual environment. So we will save a lot of hardware on this. I hope this will be exciting demo. We want to talk about which drivers you need to install and which drivers provided by VMware in our case are good and which not. We have two options here, and it looks like that only Ethernet driver is useful, but we will just talk into details in the next minute. So we will show how to squeeze the hardware which is required to run such a high availability cluster. And we will also show the live demo, and in live demo we are going to just simulate the failure of the one virtual machine, and the next we are going to simulate the failure of the whole VMware host. So we will just switch off or reboot the machine. I hope this is good enough to show the high availability here. So let us start with discussion about the setup. So in the regular setup you have mostly one or two or three. In our case, we just show two VMware hosts, and we need two servers to run OpenE DSS V6. Of course, with the synchronous replication, so all these two servers will appear as a one single high available storage for our VMware hosts. And then clients will be happy of using high available resources. So it can be some high available servers or some, plenty servers actually, or storage available to the clients. Okay. And our goal today is to squeeze this to two servers. So in the same machines we will run the VMware host. And on top of this, we will run, of course, some other virtual machines. But important is that OpenE DSS V6 will run also as a virtual machine. Of course, we need two machines to run volume replication. So these two DSS machines will behave virtually the same. So exactly the same way as here. So we have this on the physical machine, but now we move DSS into VMware and we will run them as a virtual machines. But logically, everything will be identical. Okay, so that's our goal. Next step, we will show you how to install DSS on as a virtual machine. So for this, we have prepared just the first setup. It is very simple, single ESXi server, and our goal will be to install a virtual machine, right? So we have already some of them are running, some not, and I have already one Datastore, and in the Datastore I have already ISO image of the DSS available. So how to go there? Of course, you need to click on the host. So you need to select the host here, and then you have configuration, and in configuration you need to select storage. Okay, and then mouse click, and then we can browse Datastore, and in the Datastore, of course, we can here upload file or upload folder. So you just upload your ISO file here. After uploading, we have here this ISO available. I was just uploading some files here. Okay, so we have this in Datastore, and now we can start to install new virtual machine. So I just click on the new virtual machine button, and we can choose, actually both options works. Whether when you choose typical, then later on you need to change some settings, or you can choose custom, then you can, during setup, you can change more settings. Okay, new virtual machine, let's say test DSS. Okay, so now there is an option to select Datastore, but we will have only one Datastore, so there is no more option to select. In the version 5, we select version 8, so the new one. Okay, and of our case, we have a Linux. Yeah, so for Linux, DS, please select Debian version 4 and 64-bit. Okay, that's the best option to select. And now it's a option of how many virtual cores, how many sockets. We can leave it by default. And then how much memory. 384, it will be a bit too less, so let us set 1 gigabyte. That's actually minimum which is officially required to run. Actually, the software works with a lower memory as well, but please use 1 gig as a minimum. Now the next question, which is here important, if you forget, you can change it later, but now you have option to select a proper Ethernet driver. And as we already mentioned, it is important that we are using this virtual driver, because this will make use of the 10 gigabit Ethernet, which is present in our system. So select this driver. If you forget to select this now, still you will have option to edit the virtual machine and change it later on. Okay. And now we have mentioned that we also supporting the VMware Paravirtual driver, SCSI driver. We have seen some articles writing about this, that this is a driver working faster and better, but VMware still does not recommend this in the Linux environment. Anyway, we were also trying this with Windows, but it was not so great as described. Anyway, our finding was we were comparing both, so this LSI logic parallel, and we were trying the VMware Paravirtual, and we find that even this driver, the regular driver, works a bit faster. So let us stay with the LSI logical parallel driver. Okay, then we will create new disk. This disk we will create as a start boot media for our DSS. And as when you know DSS, you know that we require minimum and actually maximum 2 giga to boot DSS from. So instead of 8 giga, I will just select 2 giga, because if I select more, this will be just waste. Okay, so 2 giga drive size for our boot media for our DSS virtual machine. Okay, great. Next is default. We can still edit and change the settings, but everything is perfect. So in this case, sorry about it. In this case, we can just finish. And okay, our DSS test is already defined. So now we can still go to summary, and we can edit the settings, or in the getting started we have also a button link to edit the virtual machine. So we need to now insert a CD-ROM drive. So we need to join our CD-ROM drive with with our ISO file. Okay, so I have shown that we have it already available. So one of DSS ISO, let me use the latest. Okay, and of course I need to click power on, connect at power on, otherwise it may be ignored. Okay, still you have options like you can remove floppy, which is not required here. So now we have the ISO inserted, so let us click OK, and now our machine must be ready to start. Okay, so I start our just fresh installed machine. We just go to console. Okay, and you see our machine is starting, and now because we don't want to just start at once, we want to run installer. So let us select run installer, and the installer will move the image, the DSS image, onto this 2 giga reserved space and will make it bootable. So actually it is a quite easy task for the installer to do it. So we need to wait a few seconds. During installation we can already check whether there are some questions. I just see the feedback about audio. Okay, so there is still no questions. We will have time for questions when we will run the demo, when we will reboot the VMware host. So we have checked it takes rebooting the host and the starting virtual machine, it takes something 7-8 minutes even. So then we will use this time to answer the questions. I see already first questions coming. Okay, the first question was, can we do the same with the Hyper-V instead of ESXi? Yes, you can do this as well, but you will need to run this faster. You will need also 10 giga Ethernet driver. We will give you the link where you can download the small update. Okay, so now we have the license screen coming. So let me click OK, and now we just need to follow up with the installer. So I click on space to select the drive and the tab to select OK, enter, and then I select start. Now the system is copying the file and checking consistency. I need to tell you that if you are running the current official version, you will need to download a small update from our FTP. So because this 10 giga Ethernet driver, okay, I will just restart. This 10 giga Ethernet driver is not supported in our current version. So you will need whether a small update or just run our latest beta, which will be available as a release candidate this Friday. So this will be available on our FTP for download. Okay, so now the machine is restarting already, and you see the difference is that it is not showing the installer anymore, and it is starting just 64-bit kernel. Okay, so now the DSS machine is ready to run, but the DSS machine still do not have any storage to manage. So we will need to find out any maybe iSCSI or maybe local disk and add into this machine once machine is not running, of course. So this can be done in the editing. So when we go to the summary of this machine and when we go to edit settings, you see we can add more Ethernet adapters and we can add more hard disks as well. So now when the machine will boot, it will just be the machine itself, but without storage, right? So you will add the storage and then you can use the virtual machine. So the setup was extremely easy. When you are trying this, you can also try on your notebook, and instead of running like ESXi, you can set up VMware server, or you can set up VirtualBox, and then you can install a virtual machine as well. Of course, the most easy is when you have the separate machine and then you run ESXi, and then you can just repeat the same what I was doing here. Of course, for HA we will need 2 machines, and then we will just in the next step to show how to do it on 2 machines. Okay, let us finish. Let us show it that this is started. Okay. Great. So our virtual machine is started. We have only one Ethernet card. As I mentioned, we can edit and send. So this machine is already available on this IP address. So when I, let's say, start my browser and enter IP, okay, 220. Then our machine is already available for us. And because this is a new installation, we need to get the trial. So we need to click here, enter our IP address, and then we get the trial key. And then after entering the trial key, we can start the machine. Okay, so that was all about the installing the virtual machine, which driver to select. And now, next step of our webinar will be to show how to run this setup on 2 machines. So we have prepared two hosts, and both hosts are running VMware i version 5. Okay, and we have luckily also 10 giga cards in our machine. So on every machine we have 2 10 giga ports. We have a switch, and that's our local area network where we can connect our clients. So description is here, how we prepared this, and how are our iSCSI, how are our IP addresses. And you will see here there is description of the IP addresses of the virtual NIC and the IP addresses of the ports in the DSS. And also here we have a, of course, virtual IP, and then we have a replication. Then that's the chart, how the system is configured. And now we will move to the setup prepared by my colleague Slavek, and then we will just okay, we will just show this live. Okay, so that's the machine already on the Slavek environment, and Slavek will start to show us the configuration of this HA cluster.
Okay, hello everyone. I'd like to show you some example configuration of iSCSI cluster and the DSS used as a storage appliance, as a virtual machine inside of the ESX hosts. This is just example configuration. Of course, it may differ dependent on your requirements in your environment. So I will start with the chart again. I'd like to show you how it's configured. We have 4 NICs in each ESX hosts. 2 1 gigabyte NICs are teamed together for redundancy, and those NICs are used for management as well as for ESX server management, as well as for DSS management and other virtual machines. Another NICs are two ports 10 gig NIC. One is configured as a VM network, and the interface is added for the DSS, and we use this interface for volume replication. So we have replication running between two DSS machines over 10 gigs. And another port is used for both for VM kernel and VM network. For the VM network interface is also exported to the ZSS, and on this interface we have configured virtual IP, which in our case is 30.30.1.1, and on both hosts we have configured VM kernel, which is in the same subnet for the connectivity. So let's go to the vSphere client, which is now connected to a vSphere server appliance. In my environment, I'm using the appliance that can be deployed from the ESX market. It's working on a Linux environment. We have one test system, which is Windows 2008 R2, which we'll be using for testing. And we have two DSSs. One is running on one host, another is running on the other hosts.
Maybe Slavek, may you show us the chart, which machine is on which host right now?
Yes, exactly. I'll show you. So the DSS, which is called primary node, with IP 192.168.248.43 is running on the host with the IP at the end 188. And another machine with last octet in the IP is 187 is running on the ESX host, which last octet of the IP is 188. So I can show you
189.
89, yeah. So when we go to the virtual machines, you can see which exactly virtual machine is running right now on which hosts. So as you can see, DSS primary is running on 188, and other three machines are running on 189. What's important here is that the Windows 2008 R2 is using right now the shared Datastore, which its name here is shared Datastore. This Datastore is the iSCSI target exported from both DSSs configured in Iskazhi Failover. So the DSS, the Windows machine is protected when you have configured, for example, high availability or storage DRS or just simple DRS. Your virtual machine that are using such data store is protected. Now we go to the DSS, so I will show you some setup, how it's configured. As you can see, it's already configured. I have failover cluster running. My first node is the primary active node. The other node is the secondary and passive node. And if I will show you configuration, this is the ATH1 interface, which is used for the virtual IP, and ESX hosts connects to this virtual IP and to the resources served over the virtual IP. Another is the ETH3 NIC. This NIC is used for both for auxiliary connection between nodes as well as for volume replication. And this is also the 10 gig interface. And the other interface is a 1 gig interface, which is here used for management, so for the DSS web GUI access, as well as for communication between nodes. Because in the Iskazhi Failover, in the DSS, we need at least 2 paths between DSSs. The same configuration is here. ATH0 is used for the virtual IP, ATH3 is used for the volume replication, and ATH4 is used for management. The NIC ordering here are different than in the chart you saw. It is because of UDEF service that gives name of the interface based on its rules. And it can happen that in your environment, the NIC order will be totally different because of the MAC address. The UDEF service checks the MAC address of the interface, and according to its algorithm that it uses, and gives a selected interface. The same we can see in the...
Slavek, maybe you can show the same, because we have 2 different machines running the ESX host.
Yes.
So we have the same story on the ESX with this virtual NIC, with the physical NIC, which are discovered by ESX. Can you show this as well?
Yes, exactly. I wanted to show it at this moment. So if we are going to the host, to the configuration and networking, you can see that I have 4 NICs here. And in this case, VMNIC2 and VMNIC3 are 1 gigabit NIC, and VMNIC0 and VMNIC1 is a 10 gig NIC. But on the other hosts, when I go to the networking, the VMNIC0 and VMNIC1 is 1 gig, and VMNIC2 and 3 are 10 gig. So the order is reversed.
Yeah, I just want to mention that when you have identical machines, then very mostly you will have the same order. But if the machines are different, then of course the recognizing sequence can be different. And then please be aware that in some cases you may have different sequence of the NICs.
Okay. Now we created 1 volume in the volume group. What I have to mention is that the storage for the DSS is the local storage. Each of these ESX hosts has a write controller with disk attached, and each of these virtual machine uses this write controller, the storage that is on this ESX host. And you can see the data store here is called local data store, which means that it comes from the local write. And the other virtual machine is using another one local data store. This is with 1 because ESX, when have 2 the same names, will give you 1, 2, and so on and so on. So DSSS does not use the shared storage, and when you are using only the other virtual machines, uses the shared storage exported from the DSS failover pair. So when you go to the volume group 00, you will see that I have created 1 logical volume. It's iSCSI block IO volume, and it's in volume replication, and it's in destination mode. It's on the secondary. On the primary, when you can see the same volume, which is exactly the same size. The same size is in the source. I have a task created here, which is running right now, and this task is added to the failover configuration, which is also currently running. Also, the volume has been added already to the iSCSI target. It's alias, it's target 0. It's added as LV000, LAN 0, and each of the ESX hosts is connected to this target and to the volume that it's exporting. Its name is SCST, BIO, which stands for block IO, iSCSI, and the shared data store is configured on this iSCSI target. As I show you already, the Windows 2000 R2 is using the shared data store, and currently it is running.
Maybe one more thing, Slavek, can you come back to DSS when we have a iSCSI failover setup? Okay.
Yes.
So when you have somewhere in every iSCSI failover menu, when you click on the question mark,
yes,
then you have a help, and then you can click on this iSCSI failover quick start. So this is
exactly
quite short explanation of how to set up iSCSI failover. So this is just one page, so there is not a lot to read, and you can just print this page, and when you set up iSCSI failover, then it will help you to run step by step. If you need more detailed information, then on our website under section how to resources, you can find the step-by-steps. So under support, then library, and in a library is how to resources, then you will find that we have also step-by-step presentations with every step with screenshots. So even if you will forget how to set up, they are very similar step-by-step. You can download, and also you can run this in your lab. But if you have already some idea how it works, this quick start will also help you to properly step-by-step set up iSCSI failover. Okay, Slavek?
Exactly. Okay. So at this stage we have running failover and with all the configuration, and we want to simulate the crash of the primary node, and we can see that we will see that the virtual machine that is configured over the iSCSI target that is on the failover will be running fine all the time. So, for example, we can run here biometer with just some performance. So we will do some sequential write tests with a 4 MB block size, and we'll add it to the main. If I would add it to the worker only, then it would be working only on one worker, but if I will add it to the host, this will be running at 2 workers at the time. The amount of workers, just for information, depends on how many CPUs you have in your virtual, in your machine. It can be also the physical machine. I have configured my Windows 2008 with one CPU but dual core.
May you please show us the disk targets, whether they are both selected? So here.
Yes, this is
okay.
Disk C.
Yeah.
And it is
and you
has
see,
been chosen for both.
We need to still set the outstanding
yes, we
IO.
can increase. Yes, we can increase outstanding IOs for iSCSI connections. So as the iSCSI is compatible with SCSI, it's based on SCSI, it can wait for some IOs. So we can increase this number. So we are running, we don't need to save our results. We are running the tests, and we have some performance here. The machine is not too quick, so this is just for your comparison. And we will perform the crash of the primary node. And I will just power it off or make it reset. So the failover will be triggered, and the iSCSI connections will be moved to the secondary node, which will become the active node. So we are waiting for the machine to crash. Our primary volume, our primary node is still the active, but our secondary node has become active because our primary has crashed and the web GUI is not working anymore here. I will get the timeout in a moment, and the secondary has become active. As you can see, the IO meter is still running and still is able to write to the destination volume. This is right now disk C, which is in fact on the iSCSI target configured in failover. Okay, Janusz, I think we'll have to wait for the machine to come up. So
yeah, can you show us what happened to primary?
The primary machine is rebooting and
okay.
starting up.
So we wait to reboot. It will not take a lot of time, but I will see whether we can answer or whether some questions.
Yes.
The first question was, can you use NFS rather than iSCSI? So, yes. In our case, it is a very similar setup to iSCSI and NFS failover. But for NFS failover, you need extra license key on the both machines. And then you can, but when you have trial, you can do this without any extra license. So you can set up for NFS failover. Actually, you can even set up iSCSI failover on one volume and the NFS failover on another volume. And you can run them simultaneously. I was running such a demo on our workshops many times. Then we were using even different network configuration. We were using bonding for NFS and we were using multipath for iSCSI. Okay, next question is OpenE certified for ESXi? Indirect, yes, because imagine for one of our OEM customer from Japan, we already made the certification for version 5 on the one, and now it is done on the second server. And our plan is also run officially on the OpenE certification and announce it during CeBIT on our new version, which we are just having still this will be as a release candidate this week. So it works. We have done this for our OEM customer. Next we will do for us. The sequence of this because of the urgency of the customer request. Okay, so this certification will be announced very soon. Okay, the next question we will answer when we will run the full host reboot, because it takes 7 minutes, so we have a time to answer the question. Now let us continue.
Okay, so our primary node has become running again. So we need to fail back to the primary node. So we have to run sync volumes. This is to sync all the changes that were done to the secondary node volumes during the primary was rebooting and unconnected. You can see the task status here. As you can see, the average speed of replication is about 100 megabytes.
So please note that we are running IOmeter at the same time, and we are resyncing the changes at the same time.
Yes.
Of course, resyncing the changes is much faster. This is why it took so short. But Windows is still running and then producing new data.
Yes, exactly. It can be shown here. The big client sometimes likes to hang, so we need to wait. Okay, in the meantime, I will run the failback. So as you could see in the task status, both volumes became consistent, so the data are identical on both nodes. So at this stage, we can run a failback, and this will move the active node to the primary node, and our primary node will become back the active one, and it will be serving its resources. As you can see, our primary node becomes an active. Our vClient came back to the life. So the IOmeter is still running, and our system as well is still running and alive.
Okay, it was a great demo, and then it was a kind of, a simulation of the problem of the storage machine, showing that Iskazhi Failover is running properly. But in the real life, much more disaster happened. So we can imagine that the primary server will just be powered off or just hang, what unfortunately can happen from time to time. We don't wish that it will happen very often, but in order to make sure that everything is running, even the one machine has a critical problem, then we will just power off or reboot the primary ESX host, and so this will just simulate a real hardware failure.
Exactly. What additional here can be important is just some additional settings for cluster configuration in ESX. It's virtual machine options and the VM restart priority. And this is the default one, and it will make that after the cluster is powered on back, it will also run all the virtual machines that are currently configured on this hosts. So as you can see, we have on the 188 hosts only the DSS primary virtual machine running. So we will simulate the reboot of the host, and this will of course cause that the virtual machine will be
Slavek, wait. Maybe we just need to comment this. If we will configure, let's say, also ESX as a HA configuration, right? So in such case, it will be doesn't matter whether this Windows machine is exactly running. DSS is transparent to the ESX HA because it has HA by itself inside. And in this case, DSS don't need to be configured as a HA machines. Doesn't matter how it is configured and what kind of failure happened, it will always provide the storage, right? So if you want to power of the ESX host primary, and let's say your virtual machine Windows is running also on this host, then and you want that nothing happened, then of course this machine must be configured as a HA guest. Okay, so just to comment this what we are showing exactly. Now we will just show that rebooting the so disappearing the hardware for our primary DSS will not stop the service.
Yes, exactly. So we will reboot the 188 hosts. We can't reboot currently 189 because on this host is the VMware vCenter server appliance working currently, which I am connected to it using the vClient. So if I would reboot the other server, I would lose the connection, and it will take too much time before the vCenter server appliance will be back and running. So I'm rebooting 188, and this will cause that the host will be rebooted as well as the virtual machine, the DSS primary node, will be halted as well. And you will notice that the transfer will be stopped for a while. This is because the resources
so now during the reboot, I've got some already comments. Reboot 189 ESX hosts is still. So we have just commented this why we cannot reboot the 189. This is because of our webinar, of our demo. We don't want to wait, half an hour for something. But we want to prove to you that DSS Iskazhi Failover works in both cases, but the virtual machines which are not configured as a HA, you will need to just restart. So we'll have a stop in the service. Or when we configure this as a HA, then it will be also not stopped in the service. This will be, doesn't matter which machine we reboot. Okay, this depends what kind of level of the configuration is prepared on the HA cluster, right?
Yes.
Good. So I will go through the questions which we have right now. So it was one question which was by meantime answered. Here, can you offer a comparison of iSCSI, vice versa, NFS failover for ESXi? I think that VMware has enough materials comparing iSCSI and NFS. I can just, in general, say that iSCSI has the most features. NFS provide a bit less features. So this is why iSCSI is mostly used. But because of some environment, people were using in the past very often NFS appliances. This is why they still don't want to change. This is why we are still selling NFS failover, right? But for all the new installations, I will rather recommend to use iSCSI failover. It's easier and actually is also cheaper and has full function set you need to run HA.
Janusz,
Next
if I could
question,
add something also. In case of iSCSI, you can use the VMFS file system, or you can format your iSCSI target with the VMS file system. In case of NFS, you have a file system which is at the bottom of the NES volume. And VMFS gives some additional features like change data block and tracking, and it's better in performance than using the ENFS for the ESXi. Okay.
Okay, the next question. Does the iSCSI replication support VSS? In other words, does it handle what is in the Windows cache? So, iSCSI replication will work with anything. So you don't need to care about it, because iSCSI replication is working on 100% synchronous replication between two servers. So the data which are confirmed as written, or they are still in the cache partly, after failover, you will have identical data available in the storage. So cache will also match these. So there will be no problem. You can really run anything, any application, and just turn off primary machine, or even disconnect Ethernet cable from the primary machine, and the secondary machine will take over, and then it is guaranteed that all the data, when you checksum the data, everything will be okay. We tested really in an extensive way. We test checksums of the data before and after failover, when we are copying and doing failover, and then we are proving that everything is okay. So because of data consistency, for the iSCSI failover, you need to use a block I/O only, because on the FiIO, if you select FiIO, which is still possible, but in this case, it may happen that the checksum will not match. So in all the documentation, you will find that for the iSCSI failover, you must use block I/O. Okay, next question. No MPIO with NFS. Right. With NFS, you can use bonding. So you can aggregate the NICs, but in this case, when you have one host only, or let's say you have two hosts, when the two hosts at the same time are using storage, then you will see some performance grow, of course, but on a multipath you will use performance grow even from single host. The difference between multipath and bonding, it is shown in our blog. So I will switch to myself and I will start our blog, and then there is one post which is describing exactly the difference. So when you just go to blog OpenE.com, okay, and here you just find the article about the ping node. Okay, there is an article, ping node explained. We are discussing what for is a ping node, and sorry. Yes, okay, that's okay. We are discussing what for is the ping node, and we are showing the difference with the failover with bonding and the failover with multipath. So we have two almost identical setup, and the first one show this with the failover, with the bonding, sorry, and the second with multipath. So you see, we have here 4 ports, ETH0, 1, 2, there are 2 ports here which are bonded, and ETH3, so the 0, 1, 2, 3, 4 ports. The point-to-point connection is always recommended for the replication. The 2 ports which are bonded, on these bonded ports we are having a single virtual IP, and storage access goes over this single virtual IP, right? And you can use 2 switches, of course. You can use one storage client like ESXi or Hyper-V or Xen. The ping nodes can be also separate, can be also simulated on the storage server, as we have in our demo today. Okay, that's a configuration with bonding. When you come back and go to multipath, then you have identical configuration but with multipath. The difference here is that these 2 ports are not bonded, and on every port we have a single virtual IP. Okay, so here you have the two virtual IP, right? The difference is that storage access goes over two cables and two virtual IPs. So you see there is two virtual IP for the storage client, right? So that's the difference. I will come back one more time to the bonding. The difference is that we have one single virtual IP, which is single IP for the storage access, right? And on the storage client, we use one single IP. Okay, we can use one single IP. We can use two ports, because in the ESXi we can aggregate two ports. Like in our today demo, we have also aggregated two ports, but we have one single IP on it. Okay, that's the difference. Please read also this article. It will show you, it will explain why and how to configure ping node, right? Okay, so if this is still not quite clear, then you can go also to our other webinars. When we talk about Iskazhi Failover, then we also discuss ping nodes every time. Good. Next question. Next question is there a recommended configuration for the ESXi server to get good performance? Okay, for the good performance, if you talk about a random performance, very important is that you run on the fast rate. So whether you have all SAS drives 15,000 IPM, of course you have a faster, better performance. And recently, a very nice feature which is supported by Adaptec cache and then LSI cascade. So max cache from Adaptec and LSI cascade, you have option to gain performance radically. So this is really, you can get the values, let's say 10 times better random IO, or even 15 times better. On the last our webinar, we were showing live demo that we were showing that something like 10, 11, 12 times better IO, random IO performance using Adaptec cache. We are also planning to repeat the same or similar webinar using LSI cache. Okay, so now let us, next question. Anyway, in one of our server has a Adaptec cache and the SSD disk, so we can show also quite good random IO when we read or write on today demo. So we can just after showing this hardware failure, we can also run IOmeter running, let's say, random IO. Then you will see that the performance is also quite okay, quite good, quite nice. Next question. Can you show the diagram again with the hardware setup? Yes. So let us show the diagram. Oh, okay. That's our diagram with the hardware setup. We can tell you one more time, and this diagram setup is also can be also available when you write email to the email address when you got invitation that you want to receive this chart. I will send you by email, or we'll send you the link. You can download the webinar, and next to the webinar file you will find also this chart. So this chart will be available also to you. So On the chart, one more time, we show that we have two hosts. On every host, we run some virtual machine, but of course, the most important is OpenE DSS, which is providing shared storage for your virtual machines. And we have 4 ports here. Actually, yeah, these 2 ports are 10 gig, and they are point-to-point connected between machines. And the first 2 ports are connected to the switch, and this is for the management. And this port is connected each other, but on this port we are running virtual IP, and on this virtual IP we are accessing shared storage, right? And that's dedicated link for the volume replication. And here is the IP addresses which we configured using this. Maybe I will switch one more time to our ESXi environment. Okay. And let us show shortly, Slavek, may you please go to the ESX network and show one more time how network is configured?
Yes, exactly. So as you can see here, we have 4 NICs, which is the same as on the diagram. 2 1 gig NICs are connected together. They are added to the same vSwitch, and on these interfaces we are using VM network. This is for connection to the NFS Datastore for ISOs. There is configured VM network for the management for the virtual machines, and the management network just to manage the ESX hosts. Another is the 10 gig NIC, which has only VM network enabled. This network is added to the at this host to the DSS primary node, and on this network, on this interface, we are running volume replication. The another port of the 10 gig interface has VM network and VM kernel enabled. VM kernel is used by the ESX host to connect to the iSCSI target served over the virtual IP. That's why on the same interface we have the VM network interface, which is added to the DSS node. In this case, we have without need to use switch 10 gig switches, we have just direct connection. And with such configuration, we have the 10 gig connection for iSCSI and for volume replication. The same is on the other ESX hosts. As I mentioned already, the NIC order is here reversed, and it depends on the MAC addresses. Here also 2 interfaces are teamed together, and they are configured for the management of virtual machines, and also for the ISO file accessing. And another is 10 gig used as the VM network used for the volume replication, and another port is used as the VM kernel and VM network for the connectivity for iSCSI over virtual IP.
Yeah, I think that's the good presentation of the configuration. So by meantime, let us check whether the DSS primary is started, because we see the host is there. It primary looks like also is there.
Yes, exactly. Primary has been already loaded. As you can see, it's up and running. We can connect to its web GUI. And we can sync volumes and fail back to the primary node.
So now we are on the secondary machines, and in the secondary machine we start sync button to get this mirrored content of both storage.
Yes.
Because I/O meter is running all the time, so we see
Yes.
there is already delta of the data which was copied on the secondary server, and this
Yes.
is just now mirrored.
Yes. And
Okay, done.
there are
And
things.
now we have the same data on the both system, and then we can run failback to move activity from the secondary server back to the primary server again. Okay, so that was the primary will just become active in the few seconds.
Yes.
So it takes something maybe 20 seconds to move it. Okay. By meantime, so we have shown the demo, and then now we see that the primary is already active, and the replication task is starting and it's running now. So when we check, then we see it's already consistent, because during the failback, it was a very low amount of data coming, and it was just by meantime already making the one-to-one mirror, right? So we are done with the successful demonstration of rebooting DSS as a virtual machine, of also rebooting the whole host. So we see that this failover works well, and we were running, during this time we were running the I/O meter all the time. So now let us answer the outstanding questions. So next was the bonding does not give better performance. That's right, I agree with you. Better performance is with the multipath, but when you have the bonding with the single server, so point to point, the bonding will give you only path failover, but will not give you better performance. But you have the bonding, and the two hosts at the same time are using these, and the amount of data which is moved over the bond is higher than 100 megabytes per second, about what is possible with a single gigabit Ethernet. Then the bonding will help in this case, because every of the host, ASIC host, will move maybe, let's say, first one will move 70, second will move 70, so in total they will be able to move 140. If there will be no bonding, then both will be able to move, let's say, 60-60, right? So with the bonding you can see a bit better performance, only in case when the bonding is used by more than one host. If single host, of course, no performance grow, and here you are right. Next question. What about the VMware tools? Can they be installed on the virtual DSS? We don't, actually for the VMware and for the other virtual environment, because DSS is failover is transparent, so you don't need to make motions or this kind of stuff. We still didn't install the tools. We just install the most important thing here is this 10 gigabit virtual driver, where you can get maximum performance of your virtual machine guest. So this is a must that you can run the high performance, and tools are actually not needed here. You have seen both primary machines have no tools, and we will, of course, sooner or later will release the version with tools, but there will be no the real advantage of this, because DSS, as I mentioned, is provide independent failover. Okay, so next, where I can download the when we are VMware tools on the DSS servers likely to be available. We plan something like to add the tools. Anyway, we can have the version first in engineering phase, so that will be official version just with the tools, and this we can do actually soon. So after releasing the release candidate one of our current version, we can also prepare the same version with tool. This version will be not fully tested by our QA because this is a long process. But when you are installing tools on some other guest by yourself, also you have no guarantee that it was tested by QA. You just need to check it whether it works. But again, these tools will not give you a lot of advantages because DSS is provide independent failover. And next question, where I can get drivers for Hyper-V. Again, send us email. To the email when you get invitation that you need this driver, we'll send you the URL link on our FTP where you can download the driver for Hyper-V. That will be also the driver to get 10 gigabit Ethernet, right? Next question, if I would not use MPIO but bonding, can I use DSS V6 Lite? No, the DSS V6 Lite does not provide volume replication and of course will not provide any high availability function. So this is for sure DSS V6 Lite cannot be used here. Okay, let us see if there is some more question. Next question, how does licensing work ESXi OpenE? So for ESX, of course, you need a license from VMware, and OpenE license, whether it run on the physical machine or it run on the virtual machine, is exactly the same license. So in our case, when we run our HA cluster on the 2 hosts, so you need 2 licenses for DSS because you need 2 DSS. Next question, does Iskazhi Failover work with DSS V6 Lite? I thought it does. No, this is the Lite version for sure does not support Iskazhi Failover. You need to buy full product. But if you are running a Lite version, you can just buy upgrade. Okay, so that was about the questions. I think we have went through all our agenda today. So we are done with the webinar, and one more question is coming. Sorry for the confusion on the licensing, but I need 2 licenses for the physical ESX plus DSS server, plus 2 more for the virtuals. One more time. In our demo, we are using 2 physical servers. On every server, we are running ESX host. Okay, so you need 2 ESX licenses, of course, right? Or you can buy a pack which is providing 2 or 3 hosts, option to run 2 or 3 hosts. And on 2 servers, we run 2 DSS machines. You have seen we run DSS primary and we run DSS secondary. We have 2 machines. The primary run on the first physical server and the secondary will run on the second server. So you need 2 instances, and for Iskazhi Failover you always need 2 instances. It means you need to buy a 2 DSS full license, and then you just need to select the capacity. Let's say you need only 4 terabyte, then you need 2 DSS V6 4 terabyte both. Next question. In the product comparison, Lite full version, we can see synchronous volume replication over LAN with Iskazhi Failover. Sorry about it, that's the mistake in the chart, and I've got this feedback already, and I was asking our web team to fix it. Okay, sorry about it. Next question. That's what I see. I'm on their side. Yeah. Okay, that I see Lite does synchronous over LAN. Yeah, this is a mistake on our website. We will correct it. So please, if you are going to run Iskazhi Failover with the Iskazhi Failover, then of course you need to buy full product. Okay, so if there is no more questions, we would like to thank you very much for joining our webinar today.